All right, hello, and welcome to our very first Fun Fact Friday video. So I figured, you know what? We used to do Fun Fact Friday. I loved it. I learned a lot. I didn't realize how much I didn't know, which is a beautiful thing to realize. I'm just going to put that out there to be like, I didn't know that. And then you get to spend the time to learn that you didn't know that. It's pretty great. So anyways, I figured, why don't we do a very quick, that's why I'm talking even faster than I normally talk, Fun Fact Friday video. And so for our very first one, I'm going to kind of discuss what is a protein. And so proteins are basically, they're not the building blocks of life, but they're pretty close to it. Like imagine if you have a series of Legos, right? Like you got your little 4-block Lego, like a classic Lego. I'm not talking like the new ones where it's like $100 and you get like a set and then it's got like weird flat pieces and you're just like, what am I supposed to do with this? And then when you stick it on another Lego, it never comes off and you're like, wow, what a waste of money, because now I have 2 Legos that I can never separate. And then build something else with. So imagine you got your classic red Lego brick Lego, right? And that's basically how you would see, like, that's DNA. That's like a particular letter of your DNA. So you have A, C, T's, and G's, and the combination of the two make that double helix. So I take that red Lego and I'm gonna put on a yellow Lego on top of it, and there I go. I have a DNA pair, like I have an A and a T in my DNA. And so let's take our little series of Lego blocks. So if we had 2 Legos stacked on top of each other and it's like a long series of Lego blocks, and then we basically, what we're gonna do is take a 3rd series of Lego blocks. We're gonna come in, we're gonna remove the pairs that we just spent all that time making, and we're gonna put the 3rd green colored Lego blocks all on top of that, and that's our RNA. That RNA is then stripped off of that red Lego block, and then the yellow ones are put back on to the actual Legos, and then that RNA is shipped off and it becomes this beautiful thing called an amino acid. That is for another Fun Fact Friday, because to be honest, I need to do a little research on what amino acids are and how I would describe them in really complicated ways. Don't. We're just gonna go with it, guys, okay? We're going with it. It's a short science video, okay? I promise you, this is a professional place. We come here and we are all very professional. We know what we're talking about. So we're gonna continue with the Lego block and we're going with it, okay? It's stuck and we're going with it. So you have your green Legos. They're now amino acids, which just kind of picture larger. So they were the little 4x4 green Lego blocks, 4x2 green Lego blocks. And now let's just imagine that they're like a 4x4. Professional. And so anyways, these amino acids are basically put together into a small series to form what we have spent all this time talking about, a protein, okay? And so this protein is basically what, I don't know, like how would you, Fun Fact Friday, I don't know. But anyways, so basically if you look here, let me show you guys this wonderful thing that we see here. This is a protein. I know it looks kind of nasty and you're just like, wow, what am I ever supposed to do with this? Like, who gives a flying hoot what a protein is? Well, your body gives a hoot, okay? Literally everything that we do, every way that we interact with ourselves is basically through these protein structures. Don't quote me on that. Literally, please don't. So anyways, you basically have these proteins here. And so this is like a combination. How do I describe? So you have your very first primary structure. It doesn't look like much, and it's literally, in this case, it's like a series of 3-letter codes, which are our amino acids. So remember that RNA and how it became an amino acid? Well, these 3-letter codes basically represent a different amino acid. So RNA a series of different letters is going to become a particular amino acid, right? And that amino acid is then going to combine with another amino acid, and you're going to get this long string of amino acids. And those then do this. I'm not even kidding you. I hope to God you guys recognize how absolutely beautiful that this is, because these strings of amino acids, they literally, what they do is they're going to, like, they twist in on themselves. They get to a point where they get long and they start to form bonds with themselves so that they begin to twist. And that's what forms this wonderful thing called an alpha helix. And then you have this thing called a beta strand right here, which is basically a sheet. So rather than it twisting, it kind of just like, it stiffens into this kind of sheet. And it doesn't literally look like this. I wish that would be really cool. Like, imagine if you just had floating curlicues and like flat arrows through your body. Like, imagine if science looked like the cartoons that depict science. And I don't even mean science, because science is literally so many different things, but imagine if anatomy, I think that's more accurate, if anatomy looked like these like cartoons that you actually see. Like, it would be really cool. I feel like the world would be more understandable, but we'd all be like walking around as colored globules, you know, rather than looking more like neutral tones. It'd be more like bright yellow. Okay, sorry, fun fact divergent. So anyways, long story short, you then have alpha helices and your beta strands that then come together, and they basically continue to twist in on themselves even more. So as these alpha helices bind with other proteins and beta sheets, they begin to kind of like twist and conform, and they want to compact themselves. Because ultimately, if you had a series of curlicues and beta strands all throughout your body, like that if they were laying flat, you'd have to be miles high or kilometers high to be able to fit just flat proteins in your body like that. So they have to compact themselves. And beyond that, they literally have to compact themselves because it's a series of different chemical reactions that make them compact within on themselves. They're basically like, hey, how you doing? Oh, hey, how you doing? And then they scrunch up, you know? Like, imagine like a giant club. Like you're in the club and Shot to Get Low with It comes on and you're like, oh my God, this is my jam. And then everyone starts dancing, and then you literally just compact your guys' selves into the dance floor so you can all fit. That's life. That's anatomy. I feel like your body literally takes the path of least resistance and safe space saving. And so it compacts itself in that regard. And when it really kind of, they begin to bind with other alpha helices, other beta sheets, and then they kind of fold into what's known as its tertiary structure. And then you finally have this wonderful, final, beautiful form of your quaternary structure, which is a combination of all these other conglomerate of proteins. And you can kind of see here with the beautiful blue, green, and pink, these are all different types of proteins. So it's literally 3 separate proteins that have come together to kind of form this tetramer. Tetra being 3. Tetra is 3. Oh God, that's not it. Tetra. Yes, it's from 4. Tetramer is 4. Trimer. I gave up on doing like a series of bloopers for this very short video because I was literally like, you know what, so far I can't even keep track of all of the blooper mistakes and blooper reels that I have made in just filming about proteins. Professional. But I figure we can do more of these like Fun Fact Friday. I'll be more prepared for the next one. I figure this is just a fun one. So anyways, so you basically have your trimer, not tetra, because tetra is 4. So if we had like a yellow protein sticking off of it, that would be a tetramer. So this is your end product. It doesn't always have to be 3. It doesn't have to be 4. It doesn't have to be 2. It's not going to be one because it's going to denature really quickly. So what happens is if I have a floating single protein like this, it can form a lot of different bonds. And that's not necessarily good. Like, let's say you expose this protein to like heat, right? It's going to literally denature. And what that means is the bonds that hold that protein together, they're just going to be like, why? And then the bonds will break. And so the series of amino acids will kind of break. It's literally breaking the protein. You no longer have an alpha helix because it literally can't bind with itself. You're breaking those bonds. It all comes back to those bonds. That's what form these. Excuse me, I kind of burped. So anyways, why should we care? Why should we care about proteins? Well, that's just a wonderful thing. In my realm, proteins are what guide viral interaction. So if you really look at it, like these proteins, as they are a series of different bonds, they also have this thing called an epitope. This is a Fun Fact Friday, so I'll go more in depth into a much longer video as to what exactly that is, but think of a binding site. So think of it like a key, right? So you basically have this key that's just floating around on the series of proteins, and it's going to bind with its lock, which is another series of proteins that happens to have the correct lock to this key. And those two proteins, or those two series of proteins, bind. And so that's kind of like the root overview of how a virus bonds to your host cell. And what is a host? You are the host. If we're being honest, humans are hosts for a variety. You have cows can be hosts, bats can be hosts. That's another later video because I will be doing more science videos and I'll be more prepared for more science videos. But anyways, that's literally the importance of proteins, is they allow our cells to interact and they allow cells of other things to interact. And if we're just looking at it from kind of like a standard point of view, like let's just look at it from my own perspective, it allows my body to react with my body and it allows my body to react with viruses. And I mean, not necessarily in the negative way, like a virus is infecting a host cell and then it kills the host cell and then goes out to propagate and basically kill other of my cells. There's also the positive side of this interaction where your body recognizes the keys of different viruses and hunts down and kills those viruses. And that's another easily like 4-hour topic. People, if you are an immunologist, I'm so sorry. This is how I'm describing it. But anyways, it's really interesting. That is my wonderful Fun Fact Friday for you guys, is this primary to secondary to tertiary to quaternary structure of what a protein is. I know it might seem like a lot because it is literally a lot, but I think it's important, you know? So if you guys have more fun facts, and they can probably be way more well prepared than this was, please go ahead and share in the Discord and let me know what your fun fact is. And it can be anything, like, come on, we want to learn, you guys. If you have a fun fact about soccer, please tell me. I love fun facts about soccer. Audio, I definitely love to know. Computer, whatever it is, please feel free to share your fun fact. Happy Fun Fact Friday, guys, seriously. Alrighty.